Hi, it's nice to meet you. Today, we'll talk about Sketch as a tool for creative process and also for content creation. I've been working on this topic for a while, but never had a chance to put everything together into a coherent story. So I'm very happy that this presentation gave me a chance to do so. Before I start, let me introduce my background a little bit. This is a calligraphy done by my late grandfather. He was a classic Chinese scholar, and when I was a little kid, he tried to teach me calligraphy, but I never had the patience to learn to do that. My father was a amateur artist. He did a variety of artwork, including pencil sketch and watercolor and oil paintings. He paints on a variety of different surfaces, not only in like 2D canvas or papers, but even on dining set like bowls and plates. He also did 3D modeling using papers and ceramics. I never figured out how he managed to do all this. As a computer scientist, naturally I try to resort to algorithms to help me figure out how to create artwork. Some of my recent contributions are in Adobe Fresco, a digital painting tools. My main efforts are in motion graphics, something that moves in a single frame of a picture, like the one in the middle, and also did some work in simulation, such as oil painting and watercolor. People often think that creation is a linear process. A great artist like Picasso has a great idea in mind, and then they just execute it, and eventually they reach the final paintings like this. In reality, the picture is more complicated. The artist often didn't have any very concrete idea or any idea at all in the very beginning what they want to create. So they start to do some experiment or earlier sketch like this. So based on those studies, they can gradually refine their idea and they will do more sketches, and which will eventually lead to a more mature work like this. So essentially, a sketch is a way for us to not only create the content, but also it's a way of visual thinking, a process for creativity. To facilitate such a process, the tool should have several properties ideally. One is low threshold. It should be very easy to use. Like everybody can use a piece of paper and a pencil to start draw something. Another good property to have is high ceiling, in that if you are willing to put in enough time and effort, and if you have the right expertise, then you can create very refined, very complex, very high quality work. This also applies to sketch. Right? Some people can create very, very amazing artwork simply using pencil and paper. And finally, this tool should have wide words in that a variety of different output can be created by different people. Then again, sketch is a process that can support this wide words metaphor. Because of these nice properties, sketch has been a very popular tool for content creation. In fact, people starting from prehistoric times had been using sketch to do artwork, such as those cave wall paintings. And also little children can easily learn and create artwork by doing some simple doodling and a sketch way before they can speak or write. Sketch can also be used to create not only drawings, paintings, and also other kinds of content, such as architecture. Architects often start their ideas by doing very simple pencil sketch, right, without going through any advanced things like engineering diagrams or structure simulation, or even like actually building the physical buildings. In movie production, people often start with something called a storyboard, and the way they create the storyboard is to use rough sketches to outline the basic ideas, like the shot, the scenes, or the frames. However, even though Sketch is a very powerful tool for content creation, it also has restrictions. Every tool can facilitate something, make something easier to do, but also restrict. So for sketches, it's mainly good for creating static content, like static images. However, if you want to do something else, for example, if you want to change the time to create an animation, you want to change the viewpoint to view a 3D object, or you want to change the shape by doing deformation, then Sketch will be less convenient. Often you have to do a lot of more work, or you have to use a different tool to achieve this. And this also this fundamental tension between automation and manual control. On one hand, it'd be good to just use a text prompt to automatically create an image, like in recent deep learning tools. It's very convenient, but on the other hand, what happens if the output is not exactly what you want? And then you have to figure out a way to either change the prompt or using kind of an in-painting or out-painting technique to gradually refine the output. Then the process becomes much more complicated and much less useful. On the other hand, we can draw every pixel by hand if we have enough time, patience, and the expertise. This will give us full control, but then it requires much more effort. So between those two extremes, between automation and manual control, there's a wide spectrum of possibilities to balance between automation and manual control. Creativity support has been a very important topic for both HCI and in art. Here are some papers I find to be kind of interesting that basically talk about and survey different tools to support creativity and also to give us insight about how people create artworks. When you got a chance, take a look at this. I provided links for all those papers in the slides, so you can just go and take a look. There's also this very nice presentation by Schneiderman about creativity support tools, if you don't want to look at the long papers. And instead, today, I want to focus on some specific aspects, concrete aspects, on how people have been using Sketch as a way to create contents and facilitate the creation process in computer graphics and HCI. In a nutshell, just like any algorithms, those techniques can either help us reduce the input effort or enhance the output quality. Let me start with the simplest, about beautifying your detailed individual strokes. Some people like me who have a kind of a bad handwriting, this system on the left can beautify our strokes for simple drawings or handwritings by simply record everything we have done, right? And then it will look at repetitive patterns. For example, the same words that have been written several times. And then it will take the strokes of the same word and simply do an averaging. So the discovery is that once we do the averaging, we can produce more beautiful results. There's also a study that find similar principle for human face, right? So the most beautiful face are the kind of a more average of all the human faces. So the work on the right is called elastic curves. It's also a way for us to beautify our detail strokes. Right? So the basic idea behind this technique is that depending on the speed of the stroke, the system will try to smooth it. Intuitively, if you draw a stroke very fast, your intention is to make a smooth curve. So the system will do more smoothing for you. Versus if you are drawing something very slowly, the system will think that you are doing that intentionally. So it will try not to smooth out too much. And if we take this idea a step further, beyond beautifying individual strokes, we can also do something similar to autocomplete for your programming environment. So here is a system that will record your drawing process stroke by stroke, just like the previous two systems. But then when it gathers enough information about your past drawings, it may start to be able to find repetitions. And then they can use those kind of a repetition as a way to provide suggestions to predict what you might want to do next, like this, right? So the red colors are suggestions. So just like the ordinary autocomplete systems, you can accept the suggestions, ignore them, or modify them to maintain full control. So this is a good way for us to kind of reduce the tedious repetitions when we're trying to draw a very detailed painting, like hatching or stippling. We also try to carry this idea a little further so that we can use the past workflows to create not only individual paintings, but also the frames of an animation. So here, when we draw a future animation frame, the system can analyze what we have painted in the past, on the past animation frames. And then it will try to do suggestions, what we might want to draw next. So the work on the right not only use the spatial repetitions as the one on the left, but also use temporal repetitions from the past. In addition to help us create detailed strokes, on the flip side, we can also have systems that provide high-level guidance for us to create better paintings. So Aaron Hertzman has this early work about start with a photograph. The system will help you create a painterly rendering outcome like this. The user can choose different brush types and then just hit a button to see the result immediately without doing anything much else. And if you want to have more control, to have a more manual process, the system on the right will let you start with a photograph, reference photograph. And then you can place the stroke one by one. And the system will decide the color and the texture for the strokes for you. So that will be less frustrated if you are a novice artist trying to create a artwork for the first time. So the output can retain the painterly rendering effect and while with some guaranteed quality. In addition to 2D images and animations, Sketch can also be used to create other types of content, such as geometry. I think the one prototypical example would be ZBrush, which is essentially a tool for people to paint the depth instead of color and individual pixels. So you can, with a pressure sensing tablet, you can sculpt an object, and you can also switch the viewpoint like this. However, this can still be a very tedious process, right? Because essentially you are painting the geometry pixel by pixel. So instead, there are other works in computer graphics that can help us create rough shapes using strokes. A good example would be Igarashi Steady. So that system essentially can deduce smooth 3D shapes based on simple user strokes, and you can change the viewpoint to draw more stuff like this. There are other later systems with similar ideas, such as fiber mesh. That's also a system to create smooth shapes using brush strokes on a 2D interface. Or work like Monster Mash, which will help you create a 3D shape, even with the correct depth ordering from a purely 2D interface. And if we take this idea about the workflow earlier for paintings and animation for 3D sculpting. We can also help people sculpt 3D shapes by predicting what they want to do next, like this. So just like the Autocomplete system for digital paintings and animations. So this system will predict what you want to sculpt next based on what you have done in the past. So all the yellow colors are the predictions. In addition to this, it can also predict your camera angle, because for 3D sculpting, you not only have to worry about what you want to sculpt, but also the viewpoint you want to look at the 3D object when you do the sculpting. And the work on the right is extending this idea further so that we can create an animated sequence of a 3D sculpting using your past workflow to predict what you want to do in the future, like this. In addition to organic shapes, sketch can also be used to create CAD or mechanical like models. So you can either do something like this. You provide a rough sketch, and the system will produce a straight line mechanical shapes for you based on some kind of a prediction system. So here the user is trying to draw a camera model using rough strokes. So the output will be not only with all the strokes straightened, but it will also give you a correct 3D shape, like this. And in addition to create kind of a rigorous mechanical models, there are also recent work, as the one like the one on the right, which will create a 3D shape, but still looks like a freehand sketch. So that looks very nice. So here is a result. We can actually change the 3D viewpoint based on a purely 2D sketch like this. All the systems I've introduced earlier allow users to create 3D output from a 2D interface. Sometimes this can be too restrictive. There are situations where you may want to actually walk into the 3D environment while you create. So one good example would be VR, right? You put on a head-mounted display, then you can see the virtual world while you put your 3D strokes like this. Or if you don't want to wear head-mounted display because you have a simulated sickness or whatever, you can also there are also tools to help people create 3D sketches in the physical world using rapid manufacturing technologies like the one on the right. So you are literally paint in 3D physically. One challenge for this 3D sketch tool is that it can be hard for people to control the precision of the movement, right? Because there's no support. So there are several systems that provide support surfaces for people to paint in 3D. So Mental Canvas is one such system. So it's basically that you can paint a 3D environment by using 2D slices on a tablet device. Right? So this is actually a startup funded by Julie Dorsey, Xavier's PhD advisor. And there are other systems that can use similar ideas. So Symbiosis sketch, shown on the upper right, is a system that will allow you to sketch in a 3D environment, not only using 2D support surface like in a tablet, but also curved surface, whatever you can find in your physical environment like this. And I think in SIGGRAPH of last year, there's also another very interesting work that's shown on the lower left that will allow people to actually sketch articulated objects with different degree of freedom of translation and rotation using this interface. So just like drawing on a piece of paper, it's very freestyle, and yet you can explore the possibility of mechanical joint connections like this. Right. So no talk today can skip the mentioning of machine learning and the data collection. So let me briefly mention this aspect. I think you all know that there are some very nice recent machine learning based painting systems, such as those from NVIDIA. So the input will be a very rough sketch or a text prompt, and the output will be a realistic paintings, like this. They use some kind of image translation and GAN-based technology or other recent stable diffusion techniques. And Hongbo will also talk about his work using machine learning as a way to support sketch-based authoring, such as generate a realistic human face from rough sketches. In addition to digital painting, there are also work that's basically using learning to create physical drawings, like using robots. Let's say co-creative with some very interesting experience like this. Data sets are very important. So this is a data set that basically collects people's drawing process to not only use as a way for training models, but also to give an insight on how people create artwork. Right? And so on the data set like this, such as this one by Google for simpler drawings. Also, the machine learning techniques are very nice, as you all have seen recently. But I think, as pointed out by people like Manish Agrawala in this article, the current machine learning-based tools are still very difficult to use, primarily because it's not easy for people to predict what the output will be. And if the output is not what we want, it's not clear exactly what you can do to change the output to reach the intended effect. So I think this is a very interesting venue for future works to make machine learning-based content creation tools more user-friendly. In my personal experiments, I've found out that it's often easier to start with a rough sketch instead of completely using text prompt to generate the desired output. So here is an example. I did a rough painting on the left, and then I also give a prompt to a diffusion-based system. Then I can create the output as shown on the right. That's better match to what I have in mind, rather than try to just tweak the prompt. Because sometimes it's much easier for me to paint what I want instead of describing that verbally. Sketch can also be used as a way for communication, or in general as a way of thinking, instead of just creating the final output. So the human writing system actually originated from drawings, like the Egyptian pictograms and the Chinese glyphs. Right? So basically the drawings eventually becomes more abstract, like writing symbols, and that led to the human civilization. And when the symbols become very abstract, they can convey not only a static shape, but even actions, with a lot of very interesting consequences. There are even some recent works that trying to use sketch as a way to do something very abstract, like constructing and learning mathematics, simply by drawing like this. Right? So if we want to teach children, for example, about how to do summation, subtraction, and division, this is a system to do so in a pictorial way by simply drawing. Sketch has also been used as a way for communication. So this is a very nice system called Talk, that's by Ken Perlin, that's Aaron Herzmann's PhD advisor. So on the left, you can see an example that with a rough sketch, the system can predict what kind of shape the user wants to generate, and even the animations, such as a pendulum swing. Ken Perlin gave a very nice keynote or presentation a few SIGGRAPH Asia's back. So you can see on the middle is the big screen, right? It's automatically generating the augmented reality effects over his camera feed. You can generate those effects simply by using gestures and strokes. You can look at the entire presentation online. I think it's very nice. In conclusion, Sketch is a way for us to think visually and as a way for iterative content creation, in addition to be a tool to create content at an end. It's very important to balance between automation and manual control. For a lot of our researchers in computer graphics, we naturally think about purely automatic algorithms. So we want to generate everything competitively, automatically, right? So the user doesn't have to bother to do anything. But in reality, people often want to have control so that they can decide what they want to reach in the end for their output. So we have, in my personal opinion, some very solid algorithms for creating different contents for different applications. A very exciting future direction is to build user interface and interaction scenarios to put together those components so that we can create tools for content creation that are as easy and as natural to use as sketching on the paper. If we visualize the content creation and the creative support tools in this Venn diagram, we can see that some tools like virtual or physical whiteboard, as on the left, they can support creativity. It's very easy for people to brainstorm on the whiteboard. But whiteboard is not usually a tool for creating the final content. In contrast, we have tools like CAD Modeler that can create high quality content, but it is not a tool to facilitate creativity or brainstorming. Sketch is a tool that sits in the intersection. It can support the creativity process and also as a tool to create a final content. Thank you very much.